Hello, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek in my personal experiences. This is a channel that is designed with you in mind. Let us dive into today's lesson. In this ultimate guide on organic chemistry, we are continuing with one of the most important topics, and that is IUPAC naming. And I have to be actually a bit slower when it comes to this lesson, because it is one of the most important sections that is questioned in your final exams. Now, what does IUPAC naming mean? It means the International Union of Pure and Applied Chemistry. That's the word IUPAC. So IUPAC, it also means the International Union of Pure and Applied Chemistry. IUPAC, what is it? It is the international body that represents chemistry and the related sciences and technologies. So this is an international authority that is involved in the naming of whether any new chemical, of all the chemicals in the periodic table, those that are new, those that were discovered, those that are yet to be discovered, the ones that are involved in naming of those is called the IUPAC. So what does it involve when naming of these molecules? So since it's international, it follows a set of rules on how you need to name every compound, so that if I'm here in South Africa and another person is in England and another person is in United States of America and another person is in Kazakhstan or another person is in Zimbabwe, any place, you need to be able to come with the same name. That's why it's called the international part of it there, the IUPAC. So which means they want to maintain a standard of naming of this. Now look at this. If we're looking at this molecule, I want to draw the structure of this molecule. The first part, you can see that this molecule is a hydrocarbon. As I told you, like to say, black means carbon, white means hydrogen. So this is a hydrocarbon, number one. Let me quickly write this. It's a hydrocarbon. Number two, you can see that it is saturated, meaning this is an alkane. I think that hydrocarbon, saturated, single bonds on is an alkane. So if I can draw this structure, how does this structure look like? I will be having, if I just draw this structure, it's carbon, which is this one, and another carbon, but I make it straight here, and another carbon, I make it straight. It's not really a must to draw it like this. Then carbon, then carbon, then I have to make them look as if the hydrogens were like this, and then after that I do this. One would like to draw it like that, but it doesn't make things easier for our lessons. But most of the time you find that they are plain, as the one I'm drawing in white, to say the hydrogen is like that. Hydrogen, 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 like that. So we have our structure like this. Let me take it lower now that we have managed to come with a structure. Now, what is the first thing that you need to do is to first find the longest chain. In this one, let's get the longest chain. The longest chain then will tell us what name to come about with. So we have got carbon 1, carbon 2, and carbon 3. How do I identify the longest chain? You kind of start with a straight line like that without breaking the line. So you can see that this has got what? The straight line has got 3 carbons. And you remind yourself to say 3 carbons. Remember, it's methane, ethane, and prop. So you're like, if it's an alkane, this molecule will be called what? Propane. It's a simple molecule. It's an alkane, 3 carbons, it's propane. So you see what you do? First, identify the longest chain. It's an alkane. How do you know? Carbon and hydrogen. It's saturated, there are no double bonds, so it's simple propane. Simple as is, this lesson will actually focus on alkanes for now. Let's go to the next one now, just to tighten the belt a little bit. Now look at this one. I'm going to draw again this structure here, but this structure, as I said again, this is a single line because I'm moving on a straight line. See, from here I'm not breaking, it's a straight line. If I can stretch it, it will give me this molecule. I have got carbon 1, 2, 3, 4. That's what I'm having. And then, as I said, these are the hydrogens that I have to fill in. We have done previous lessons now that makes you be comfortable in doing this. So I will also encourage you to pause this video and come with the structure of the molecule that I'm showing, the next molecule. So look at this next molecule. If you can try to come up with a structure here. Look, I want to move, it's either go from 1 to 3. This is 3 carbon. Then I told you this other one, you see, it's a branch like on a tree. Or you can say, but I want to move in this direction, to say 1 and 2. Even this other one is a branch, it doesn't matter, but in carbon number 2 you will always find a branch. So if I'm to draw that structure, this is how it will look like from a carbon, 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 and in carbon number 2 I have this branch. I hope this is making sense. Now, since I've got these molecules, remember, maintain carbon with what? A minimum of 4 and a maximum of 4. So these are saturated, meaning number 1, they are saturated single bonds, and at the same time, let me be careful there to track everything. Saturated single bonds, and then at the same time they are what? They are hydrocarbons, means it's hydrogen and carbon only. If I want to name these two compounds, look at this. That is where now we come to the part, I think we discussed this, to say these are isomers. Why do we call it isomers? Same molecular formula but different structure. Now the structure here, this is a chain isomer. This is a chain isomer. Let me put it just on top because I don't want to disturb what I'm having here. This is a chain isomer, and in this chain isomer, the chain is different. We've done this before. Now let's look at the first one. How many carbons? 1, 2, 3, 4. It's an alkane with 4 carbons, and 4 carbons, remember, number 4 is but, which is, this is simple butane. Now before we can do that, I will advise you to do kind of a condensed structural formula, but this is how I prefer the condensed structural formula. The first carbon is CH3, the second one CH2, the third one CH2, the fourth one is CH3. I will advise you to start with this kind of a condensed structure. When you've done that, you can see that simple here is how many carbons? You have got carbon number 1, carbon number 2, carbon number 3, carbon number 4. Then you can now clearly say, indeed, this is butane. If I use the same method here to say, on the second one, to say, let me come with a condensed structure that is similar to this, what I have, the first one is CH. Let me go a little bit down. The first one is CH3, and then the other one, look at this one, it's CH. It's up to you where you want to put it. You can put it down here, CH3, it's fine, but let me put it on top for the sake of the diagram. I've got CH3, and then after that I've got CH3. Now I want you to pay attention to this. Now when you look at the chain, the straight chain is the one with the carbons. Look at the straight chain. This is carbon 1, carbon 2, and carbon 3. So the straight chain has got 3 carbons, and then we have got this group, and we call this group the branch. Now there are 3 types of these groups that you 2 types that you're going to have to know. The first one is called this, you see, is that and CH3. This is called the what? The methyl group. It's called methyl group. Always remember that. So how do you draw the structure? It's C, that, and that. I think you can pick it up from the top here. You see, if you cut this, you will come up with the one I just did here. This is the methyl group. And then the second one, it's like this: CH2, CH3. This is called the ethyl group. You are supposed to know these 2 for your syllabus. Then if I say draw for me the ethyl group, it's C. It's very important to put this line to say it's not complete. Then C, H, H, and H. This one has got 2 carbons, but it's missing 1 hydrogen. Remember, usually there is a hydrogen here to make it an ethane. That's why it's called the ethyl group. If I put hydrogen, it becomes ethane. But now, if I knock off this hydrogen, you change it from ethane, and then ANE, you put YL, ethyl, becomes an ethyl group. Just like methane, if I put an H here, this becomes methane. But because of the outstanding or the missing H, you remove the ANE, it becomes the methyl group. Very, very important. Remember, you'll be asked of the 2 groups of branches. Is either the branch is a methyl or the branch is an ethyl. So in our structure here, if I can now erase this part, in our structure here, you can see that this branch is a methyl. It's a methyl branch. So this branch is called methyl. So, and you can see that methyl is in carbon number 2. So that is the methyl. So how do you name this? When you're naming, identify the longest chain. The longest chain says is 3 carbons. And you ask yourself, 3 carbons is what? 3 carbons is methane, ethane, propane. So you're like, okay, the parent chain, that's what we call the parent chain, is the root, that is propane. It comes from propane. But now, since you know it comes from propane, that's number 1. Number 2, there is a branch called methyl, and it is in the branch is in carbon number 2. So how do you write the final name? When you're writing the final name, you're going to say in carbon number 2, then between the number and the letter there is a hyphen. You will tell us that there is a methyl, and then propane. That's the name. I repeat again. It says 2-methylpropane is the name of the structure. What does it mean? It means go to carbon number 2, you'll find a branch called methyl, and the parent chain is propane. That's how you name this. Are you with me? Now, let's do quite a few of these activities, but what I will encourage you, if you are now ready to be naming this, you pause the lesson, try to name it yourself, and then if you've named it, then let's compare the answers. Let's start with this one. What do you have to do first? Convert this into a condensed structural formula, try to name it, and then you check my own naming. So I'm going to convert this into a structural formula. The first one, you can see this is carbon number, let me do it. This is carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and then carbon number 6. This becomes my straight chain. See, that's my parent one. It's my straight one. Then this becomes a what? This is a branch. See, if you are able, you can already name it from here if you've got my experience, but I prefer to start by saying CH3, carbon number 1, CH2,
couple number 2 CH3, couple number 3 CH2, couple number 4, so it's just CH2 now. So this is 1 2 3 4. Couple number 5, look at this, it's CH, and then I've got CH3, and then couple number 6 is CH3. Now look at this one. The longest chain is couple number 1 2 3 4 5 and 6. You remind yourself, these are alkanes, saturated, they are not double bonds, it's only carbon and hydrogen, it's a hydrocarbon. So 6 is hexane. So first of all, I know number 1, it comes from the parent called hexane, and then I look at carbon number 5. Look at carbon number 5, I have a branch. So in carbon number 5, I have a branch. What is the branch called? It's a branch called CH3. See that? It's a CH3 branch, and we call this the methyl branch. So carbon number 5, I've got a methyl. And then the final name, what to do? You mix it now. It's 5, you start with number 5. Now between a number and the letter, it's a hyphen. And then you've got methyl. Don't forget, a number and a letter, that hyphen is important. But don't space now. If I write hexane, you don't space. You write in the same space and then you say hexane. You don't space. 5-methyl hexane. That's the name. So you can actually, I can give you 5-methyl hexane. You must be able to draw that structure. Continue. There is another one. Can you try it? Identify the longest chain, and then after identifying, you know where it comes from, and then you know the branches and stuff like that. Now let's identify the longest chain. The longest chain, remember, the longest chain is the chain that has got the most number of carbons. So I can do this one as my longest chain, and then I can try another one like this. It's still a chain. I can try another one like this. It's still a chain. The one that will give me the most carbons is the one that is chained. So let's start here. I've got carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, I'm using the red, carbon 6, and then I've got carbon 7. This one has got 7 carbons, the red one. Now let's try the pink one. It's carbon also 1, 2, 3, and 4, and then 5, and then 6, 7, 8. You see, this one gave me 8 carbons. Obviously, the one that is blue is 4, and that is 5. It's 5 carbons. So you can see that this one is not gonna work, and this longest chain is the straight one. So if the longest chain is the straight one, so far so good. Now, careful now, pay attention. Pay attention. I'm going to number it in 2 parts. Let's start from the left to right. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7, and carbon 8. Now I'm going to name it. This is this direction. The red is this direction. Now I'm going to use the blue, which we're going to call this direction. So it will be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7, and carbon 8. It's obviously the same number of carbons. Now I'm going to give the name of the structure for the one from left to right. From left to right. So this is the direction. Let's give it a name. Now, whatever you see, this is a branch because it's not part. Remember I said it's a straight line. When you're looking at the longest chain, it's a straight line without lifting your hand. The moment I want to come here, you see, I have to lift my hand and come back. That becomes a branch. That becomes a branch. Are you seeing that? So the straight chain, even if I was coming to say you're coming to this direction, look at this. I'm not lifting my pen. I'm not lifting my pen. That is still a straight line. The fact that it's going down, it does not mean it is a branch. Please, you can still go down and it will still be a straight chain. Are you with me? But now from left to right, look at this. What am I coming up with? I'm coming up with a branch. And what type of branch is CH3? I said CH3 is called a methyl branch. And then what about CH2CH3? CH2CH3 is also another branch. It is called an ethyl, from ethane, ethyl branch. You need to know these two branches, very important, methyl and ethyl. So how do you name these? It means, let's start with the what? With the longest chain. The longest chain is carbon number 8, so we know that it is octane. And then after that, we know that in carbon number 4 we have ethyl, and we also know that in carbon number 5 we have what? Methyl. Now let's come with the final name. What is the final name? This is the final name. Now when you're naming this, it becomes this. You start with the alphabetical order arrangement. So the alphabetical order says 4-ethyl. Why? Because E starts before M in the alphabetical order. So you'll have 4-ethyl because E starts before what? Before M. Don't say 4 starts before 5. The numbers are not important. What is important is the alphabetical order. The E and the M. Ethyl, methyl. So E starts before M. So 4-methyl, remember, the number hyphen the letter. Now I need to now put the other branch, which is 5-methyl. Again, between the letter and the number hyphen 5, and then again the number and the letter hyphen methyl. See how we're doing this? So it's 4-ethyl hyphen 5 hyphen methyl, and then no space, you write octane, the parent. That is the name. 4-ethyl 5-methyl octane. That was from what again? From left to right. What about from right to left? We are going this direction. You look at the same way. If you are doing that, what we have on the branch in carbon number 5 now is still octane. It doesn't change. But in carbon number 5 we have ethyl. In carbon number 4 we have methyl, and the name here becomes what? You just change. Still E starts before M. It will be 5 ethyl hyphen 4 hyphen methyl, and then it's one word, remember, you mustn't break the name. And then what? Octane. Now the question is, which one of these two is correct? The correct one is the one with the minimum number. The minimum number is the correct one. And here you can see that since according to the alphabetical order, ethyl must start before methyl. So ethyl is number 1 according to the alphabet, than methyl, and we have to take the numbering that makes ethyl the priority. So the numbering that makes ethyl number 5 is wrong because it is now the bigger number. You need the one that makes ethyl the smallest number. Are you with me? Sorry. Let me check again. Yes. This is correct. Okay. Look, the number that is making ethyl bigger, look at this one. It's 5-ethyl, but the first one is giving us 4-ethyl. The other one is giving us 5-ethyl. If ethyl is the priority, you take the one that is giving ethyl the smallest number. So in IUPAC naming, you are always looking at the least numbering. That is what takes priority. You don't want the highest numbering, you want the least numbering. So you see, if I have 4, 5, now which one is priority? Is ethyl, which is number what? Number 4 is priority because 4 is smaller or lower than 5. So the right numbering is that one. Guys, there are more that were coming after this. My time is up, but I'm going to be continuing with this one continue numbering, there is another one. Continue numbering, there is another one. We continue numbering, there is another one. We continue numbering, there is another one. And lastly, that. So what am I trying to say? Definitely just follow up on this lesson. Give yourself a little bit of break. Come back to this lesson because we're still looking at IUPAC naming of alkanes, hydrocarbons which are saturated. Just stay tuned for the next lesson. We have come to the end of the lesson for now, but because of this lesson being long, I have to cut it up here. Thank you.